Hello and welcome to this Automation Academy Mastering the Machine webinar for February 5th, 2021. Today's guest is Jeff Buck, VP of Engineering for Automation NTH, and he's going to be filling us in on what Automation NTH is up to. He'll be discussing digital twins, the OEE optimizer software, and how they go about doing projects and working with their certified automation partners. Hope you enjoy it. So we'll go ahead and get started here. This is an Automation Academy webinar. This is about the 10th one I've done since August. If you don't know what the Automation Academy is, it is a kind of a membership site where I do training and that sort of thing. There's somebody else coming in. I have videos and things like that, and so people join and we talk about systems integration subjects and PLC programming, HMIs, that sort of thing. There's somebody else, and it looks like Mr. Dan Barber's on with us. We all know Dan, right? Dan is also an Automation NTH guy from out in San Diego. Got a bunch of people showing up. I have to admit them one at a time. In any case, this is about the 10th webinar we've done, and the second that I've titled Mastering the Machine. And where this comes from is originally I started my own site as a PLC training site, and then I found out that the members that were joining were more interested in systems integration than they were in just PLC programming training and things like that. So we've kind of shifted gears. And last webinar, we talked with Doug Allward, who is a guy I used to work with in applications, and we talked about kind of where application analysis comes from and things like that. Got a little bit into various different applications I was working on and he was. And then I invited Jeff Buck to meet with us this week. And I've actually known Jeff for quite a while. When I moved here to Nashville, I started working for Wright Industries, and Jeff had worked at Wright Industries, I think about 6 or 7 years before, but had joined a friend of his, Brent, and they had started up this Automation NTH company. And when I moved here, my wife needed a job and actually went to work for Automation NTH as a panel builder way back in 2006. So I got to meet with them and introduce her. She went to work there. And then when I left Wright Industries, which is a big machine builder that we all worked for at different times, I actually contracted to Automation NTH and went out to some of their customers and got to do some programming and things before kind of entering into my training career in 2013 or so. So on and off, I've done some training for Automation NTH, things like that. They're located maybe 15 or 20 miles away from me here in the Nashville area. And so I'm going to introduce, looks like Phil Scruggs is joining us too. Hello, Phil. So Jeff Buck is the I incorrectly titled him as the VP of Operations. I believe they have kind of moved things around. So he is the VP of Engineering at Automation NTH, and he was the creator of NTH University. NTH University is an internal program that Automation NTH uses to train their interns and their employees. And they've also, as I'll show you in this little picture here, also gone out and taught some of their customers. So they use some of these different training units here with PLCs and HMIs and vision systems, things like that, to teach some of their customers. They'll bring people that maybe project managers, things like that, that don't know a lot about automation, bring them in and teach them a 1-week class on PLCs and HMIs and vision, things like that. So I don't know how long NTH University has been in existence, but probably at least since I've worked with NTH, so at least probably 7 years or so. But at this point, I'll let Jeff take over, and I'm going to turn the screen share over to him. We'll see how this works. And so hopefully everybody just sees a bunch of attendees there, and we'll let you take over, Jeff.
Sounds great, Frank. Good morning, everyone. Jeff Buck here, Automation NTH. I've known Frank a long time. Frank, you need to enable me to be able to do the screen sharing here, it looks like, if you want to get that set up.
How does that work? Let me see here.
It says you have screen sharing disabled at the moment.
Huh. Share screen. One participant can share at a time, multiple. Did that work?
Yep. Give me a second here. Get this going. All right. Well, good morning, everybody. So I thought what I would do this morning, I appreciate Frank inviting me, excited to be able to speak to everybody this morning, talking about kind of what we do here at Automation NTH as a control systems integrator, kind of the space that we work in. And as we go through our presentation this morning, I'd like to talk about, kind of what we do, how we serve our customers, and then also speak to some recent trends and things of that sort we're seeing in the automation space. Speak to NTH University, which Frank alluded to just for a moment there. And then maybe we could have, if there's any questions, kind of an open question and answer session at the end. Just kind of speak to any questions anybody has regarding systems integration, machine building, training, things of those sort. So hopefully everybody can see my slide here on the presentation. Is that a true fact?
Yep, I see it.
Yep. Okay, perfect. So Automation NTH, we strive to be your trusted partner in automation. That's kind of the goal that we have set for ourselves, to partner with companies to help them kind of walk this automation journey, so to speak. And the way we do that is we provide automation consulting. We can provide custom automation, and then post installation, we can certainly support, optimization, things of that sort. So this is a cool video of a pretty high-tech machine we've delivered in the last several years. Lots of robotics, high-end servos, so fun stuff. So just a little background overview of Automation NTH. So founded in 1999 by Brent Thomas and Dennis Jones. I joined in 2003. I think I was employee number 5 at the time, and worked in the Nashville office. Was our first location, actually Laverne, Tennessee, halfway between Nashville and Murfreesboro. And as of January 1st, 2019, we opened an office in Poway, California. That's actually where Dan Barber is, who's on the call. And so we have several staff members there. So if you look in the pictures on the right, the top picture is our new Laverne facility. We moved in March of 2020, which was certainly an interesting time. And then the lower photo is our Poway office in Southern California. And we really focus our efforts in the discrete automation space, specifically in life sciences. Hence why we opened an office in Southern California, to service a lot of our customers kind of in that market. And that's been very successful. And we really focus our efforts to be an industry leader in kind of the control systems integration space. And we do that. There's just quickly speak on some awards and recognitions. We're members of CSIA, Control Systems Integrator Association. And so it's a great organization. Get together and talk about best practices for what we do in our business. So I certainly encourage everyone to reach out and check out CSIA. And they actually go through a process of, if you kind of follow the best practices on how to run your business, how to have contingency plans, lots of different benchmarks that they run you through, you can actually get certified. And we were certified back in 2018, and proud to be certified as CSI members. Interestingly enough, back in 2020, we were selected as Control System Integrator of the Year by Controls Engineering Magazine. So that was exciting. Got to go to Chicago and do some on-site interviews there. And then some other, fun facts. We've been selected as a great place to work, one of the fastest growing companies in America that are privately held. So lots of good stuff going on at Automation NTH. And then just to kind of shift gears, talk about our model, which is different than most, machine builders or companies that provide turnkey automation solutions, control systems integration support. And to do that, I'd like to talk about this from kind of the perspective of, a manufacturer who needs to have some automation equipment to make some product, right? And just talking about the automation life cycle, typically that involves, you need to create a plan, you need to find some way that we're going to scale this thing up, turn that plan into, some sort of automation equipment, whether that's manual, semi-auto, fully auto, whatever that looks like. We're going to have to scale up to deliver that product. And then we need to somehow maintain that, keep it running, optimize it for maximum content.
Can I ask a question, please?
Sure.
Sorry for interrupt you, but I'm not good enough for understanding and speaking English because I'm from Egypt. So you are now talking about how I can create a product for this company by using the creating plan or scale or maintain, using the automation cycle or using the PLCs or inverter like that, right? Or am I wrong?
Yeah, so this is kind of a high level looking at the steps a manufacturer will need to go through to kind of create a plan for bringing a product to life and be able to produce that, right? And so these are just kind of benchmarks on the different areas that they will need to go through to bring that product to life. And what I'd like to do here is to see if I answer your question. Let me kind of go through this slide and the next, and we'll circle back. And so what we'd like to do is partner with the manufacturer to kind of collectively work through these various phases. And we're more than happy to work in one phase or multiple phases as makes the most sense. And so let's talk about creating a plan, what that might entail. All right, so talking about the creation of the plan. So typically that involves, we need to come up with some sort of architecture. How are we going to do this? That involves, concepting, coming up with different ways to solve a particular problem. And as you work through those issues, ahead of actually starting to build any equipment, you might want to go through some simulations to figure out, is this feasible? What's the timing going to be? Is it going to give you the production output that you're going to need? Go through some, return on investment scenarios, things of that sort. And it could even turn into where there's particular areas on a system that might be a higher risk. You're not quite sure it's going to work, and we need to go through some prototyping, right? Maybe do a proof of concept to see, does this part of the project, is it really going to work like we think it is before we invest a lot of money in the full automation project? And then kind of moving forward, as that comes into, becomes more clear, you start going through the process of, okay, we need to engage in actually getting some equipment made. And, what does that look like? So we help scale up to where we can help provide turnkey automation system, modular automation systems, or really just the control systems integration piece, if that makes the most sense. And so you go through this kind of project execution phase where the equipment is built, goes through acceptance testing, is delivered to the facility, train up, and at some point, hopefully that equipment gets turned into where it's running production. And then kind of moving forward, you have to live with this equipment. We kind of transition to the maintain and optimize phase of the life cycle where, you're really trying to optimize the system, get as much out of it as you can. And so the way that we help with that is provide some tools such as machine analytics, so you can get some insight into, what knobs and levers you need to pull and twist to really get the maximum output of the system, get the most OEE, overall equipment efficiency. And, it's also important that you're going to have to bring in staff to maintain that equipment, a maintenance support staff, technicians, operators. So certainly training is a big piece of that. I know that's something that Frank's particularly passionate about. And then, site support. How can we support a customer remotely or on site as makes the most sense? So these are all areas that Automation NTH has offerings. And that kind of talks about the different phases, kind of in a big picture scheme, and I'm going to go through an example that kind of walks through all of those elements on a specific project that we did, so you can kind of see what that looks like in real life. But one of the things about Automation NTH I should point out is we are, as a control systems integrator, most of our staff are really electrical designers, electrical engineers, programmers. We do not, within Automation NTH, specialize kind of in the mechanical space. So we do not do mechanical design. We do not do, we don't have machining centers to cut the metal, things of that sort. And so how we go about providing turnkey solutions is we partner with companies that provide those things, and we call those companies certified automation partners. So it's part of our CAP program. And so we work with those CAPs to find out how we can find the right CAP for the right application to, provide the best outcome for our customers. And, our CAPs are all vetted and qualified. Automation NTH, we're really specialized in kind of that control space. And so even working across multiple CAPs on a given project, we can provide a very consistent control solution, which has been very well received by our customers. As automation has moved forward over the years of my career, been doing this for 20 plus years, when I first started, a lot of machines were very mechanical in nature, are almost like Swiss watches. You could see this big mechanical system. It would index. Everything was mechanically linked, and it was a beautiful thing to watch run. Moving forward in time, it seems like it's become more and more servo-driven, robotics-based, all elements that require a lot more programming. Of course, in the age that we're in, there's really a desire to consume a lot of data on the equipment. Tell me how my machine's running. And so we've seen as things have gotten more and more controls intensive, that portion of the project has gotten larger and larger. And so we have a lot of customers that say, hey, Automation NTH, we really want you guys to kind of be the prime for the project. We want to give you we want you to provide this solution to us and work with your CAPs to, turn that into reality. And so by having multiple CAPs, we are able to provide different capabilities in different regions or even different scale. So we have CAPs that are pretty small, 2 or 3 folks, to CAPs with hundreds, if not thousands of employees. And so we can really allows us to scale up and down to meet our customers' requirements. And so our CAP model is somewhat unique and different than a lot of customers in our space. And we think it's, something that really separates us and provides lots of benefits, which I'd like to talk to. It gives us a lot of capacity for rapidly, scaling up. With this model, we're able to provide accountability that our customer gets a single point of contact while having the benefit of getting, the best from different automation vendors. And we think that it really mitigates risk on our customers' perspective because they know they're going to get a consistent controls outcome across multiple automation systems, potentially reduces handoff from different customers, different teams having to work together. And so these are some of the different areas, speed, flexibility, really allows us to engage with the appropriate CAP that has, we have some CAPs that are really good in automotive space and others that more in the life science area, which is, clean room kind of expertise is required and a little different mechanical expertise in those different spaces. So yeah, that's kind of a high level overview of our CAP model. And just to talk through the journey of a specific project, I'd like to talk about, how did we go from a project where we did like early on in that planning phase, we talked about how we could do like a proof of principle, a proof of concept. And so we engaged a customer who had a challenge that they had been working with for years back in 2017. And we're going to talk about the story of going from that through ramping up through full automation systems, as you see in the lower right-hand corner right there. And how we did that, just kind of talk through that timeline is we engaged in that, planning phase and went through and really attacked this problem that they'd been trying to solve for many years and unsuccessfully. And they were doing this process completely manually. And what it was essentially inserting something really small inside of something else really small, and it had to align those things. And so they had operators with big magnifying glasses trying to do this process. And there was a lot of challenges to it. And so we kind of brainstormed an idea and did this proof of concept machine, which proved to be successful. And they're like, okay, well, let's transition now to we need to start ramping this up to a semi-auto solution, which is the second photo you see from the left right there. So we concepted, did a bunch of simulations to show what this manual concept would look like, and went through and actually turned this into where, it was a semi-auto machine. You would load a few parts and pieces, hit an opto touch button. It would assemble this product, and you'd have a kind of a finished product that you could use and sell. And then that quickly transitioned to, okay, we need to ramp this thing up quickly. We're going to need a lot of production. How can we meet this production requirement in a more fully automated solution? So we did a lot of simulations. You kind of see some simulation right there. I'm going to show you some more simulation on my next slide here in a second. But we did a bunch of testing to figure out how we could do that, solve that problem, and involved a bunch of tray loaders, and kind of took the heart of what we had done before and really, expanded on that to where within this timeline of roughly 18 months, we went from solving a problem that they had failed for many years to having a fully automated solution running production on their floor. And I think that to date, we have delivered over 20 of these systems to help them ramp up and deliver this particular product. And so before I get
sir, can I ask a question about the last slide?
Yes.
So the mission or the vision for the company to create the production lines for the customer need to build a company, a production line, right?
Yeah, really our vision is to help our customers succeed and compete on a global marketplace. We do that by being the architect of automation. So really our goal is not to provide turnkey automation necessarily, but to help be the architect. And a lot of times we feel like we're the best solution for providing that turnkey automation, but that's not always the case. We want our customers to have the right to be successful in whatever they're doing. And so sometimes it could be a manual solution is the best approach, depending on their production requirements. And so we do provide turnkey automation, though. That's a true statement. Did I answer your question?
Yeah. Thank you.
Okay. And so as we've gone through this journey, one of the things I'd like to do is, are there any other questions about our CAP model or about automation NTH? I'm going to kind of shift gears a little bit and talk about some of the trends that we're seeing in the machine building systems integration space. All right. Seeing none, let's talk about some trends that we're seeing. So I'd like to talk about, you hear a lot of talk about digital transformation and digital twins. And so I'm going to talk about that a little bit and show you some examples. And also going to talk about virtual acceptance testing. So, many years ago, this was something I would have never have thought would be possible. We have a machine that needs to be accepted. A lot of times we'd have our customers come on site, go through a factory acceptance test. There's certainly been some challenges in the last year due to COVID and other things. So we've found that there's been a desire and almost a requirement to figure out a way to do that. And we've been successful in that. I'd like to share that story a little bit. And then we also see just this desire for more and more data. You hear the IIoT, Internet of Things. We want big data, data lakes, and just tools to be able to diagnose what's going on with my system. How can I make it the best it can be, right? And so we're going to talk through these elements here a little bit. And so to start off with, I'd like to talk about kind of the digital transformation and twins concept. And so there's kind of several different areas in this. So talk about simulation, and this talks through these examples that you see right here are particularly aligned with that storyline we just talked about, that journey. And so we did some initial prototype simulations, which you see on the lower left-hand corner. And so, you know, you can actually develop the mechanical space. We had some robots involved in this particular project with some Cognex camera systems, and kind of laid all that out in space and go through the process of, is this going to work? Is this the physical right dimensions? That's kind of the first thing, is can we make it fit in the mechanical space, right? That's one aspect of simulations of why you might want to do that. And you can also go through and do the timing, you know, how long is this going to take to make a particular cycle? And then, you know, we kind of transition to the full-scale production simulation. It just kind of builds on what we had done there. And then on the far right, you see the operator simulation. So this is actually showing, you know, what's it going to take for an operator to deliver the equipment, the raw materials to the systems, and then remove the completed product from the cells. So you know how many operators you might need, what that production flow is going to look like. And so that particular simulation you see right there was done using a product called FlexSim. And so it's a pretty powerful tool that lets you go through and develop kind of this digital twin, kind of a replacement for the physical system with the digital version, to see how you're going to interact with the system. It's really the concept of digital twins, is allowing you to test things in a digital space, digital way, before having the real system built. And another tool for that is this Emulate 3D. It's a new product that Rockwell Automation has come out with. I would invite you all to go check that out. There's some really cool demos on Emulate 3D that you can see. And within that, there's different kind of tiers to what you can do. You can do the simple, you know, simulation, where you're just kind of seeing, does it work within the physical space constraints? You can actually, you know, do more of what you see on the lower right-hand corner. How does the product going to flow through? Where do I need? Where's my bottlenecks going to be in the process? And you can even go so far as you actually can write your code and hook it up to where you can actually test your PLC software with this simulated system. So there's actually, like, you know, there's a cylinder that moves back and forth, and inside the simulated software, you actually tell it, you know, when you get this input to advance, you're going to advance, and you're going to wait for this advanced sensor to turn on. You put all kind of the physical constraints in, and it actually will test your real PLC code. And that's kind of the concept of the digital twin. And we're seeing that demand go up. And there's actually some requirements. We have customers that, you know, working in the life science space, they have to do a lot of validation and, you know, a lot of test cases. And to go through all of those on the physical system can be a challenge. And so they've actually challenged us to create digital twins specifically so they can run through all of these test cases. You know, what happens if we do this? What happens if this happens? To kind of validate that the PLC code will respond in the correct way and provide the right fault indication. Does the, you know, things of that sort. And so it's very interesting to see kind of the desire to go this direction. You know, it does take some extra effort to go through these steps, but you know, when you get to the physical build phase, you can find that there's some time savings on actually bringing the system to life, because you, in a lot of ways, you kind of checked out and validated the controls portion. So any questions in this area before we move on?
I have one question, Jeff. So you mentioned that you guys do the electrical design. You have lots of CAD operators and people doing electrical design, but obviously here there's a lot of 3D modeling of, you know, pretty detailed 3D modeling all the way down to the component level. How do you outsource that, or do you do that in-house with things like SolidWorks or Pro E?
Yeah, great question. So the short answer is yes. We do some of this internally. We do some of it through our CAP model. So we engage our CAPs to help us as needed. And so to a certain extent, we're not doing the mechanical design piece, but we are the programming experts, right? And so we might ask our CAP to create the mechanical SolidWorks model that you might see here. And then we use that with, just take example, the lower left-hand one there. That was actually a simulation done through the Epson software package. And so we actually did the simulation using the Epson software package. You bring in the physical space, you drop in your robots, and you actually go through and you teach all the different points, and you can run through that simulation. So we actually did that simulation building on the 3D model of the physical space that our CAP provided to us in that particular instance.
Okay, so you've already got by that time, you've already got the project. This is not something that you would necessarily use to pitch to a customer. It's something that it would already be funded. They're wanting to do prototyping and that sort of thing.
Yeah, it depends. This particular project was funded. We were doing an engineering study, a proof of concept, funded proof of concept project, and that's what this was funded under. But we have done, simulations kind of in that quoting phase to win a project. So certainly the depth that you go into can vary. So, until it's a funded project, quite honestly, you do kind of as little as you have to prove that it's going to work, right?
Okay. Yep.
Good question. Anybody else have any questions? All right, awesome. Let's talk about virtual acceptance testing. And so, due to COVID-19, there were certainly a lot of travel challenges in the last year that I'm sure you all have had to deal with. And, we were challenged where we had some production equipment that was finishing build, and we needed to go through the factory acceptance test, but our customer couldn't come in person to see that equipment. So we developed basically a way that they could live stream the equipment running through this product called Obs Studio. And so it's basically a product that you're able to take different video input, like from cameras, webcams, even just, artwork, and you kind of piece this together and you're able to basically provide an output of, whatever you'd like it to be. And so what you see in this particular image was a snapshot inside of a particular work cell that had a couple web cameras. So, you're kind of looking like you'd actually see the robots moving around, things of that sort, just like you're standing at the door looking through the door, Lexan or whatnot. And then we had some Cognex, in this particular case, Cognex inspection processes happening. And so you can kind of see the up close images of some of those inspections. I've kind of blurred those out so you don't see the real product in this particular case, but you can kind of see up close what's going on with the product as well, right? And so it really allowed you from, a customer sitting in, near our Poway office in California could watch equipment running in Middle Tennessee, and it was almost like they were looking through the door of the equipment, right? And so it was quite beautiful. And we would have a series of systems, and it would just kind of, would show this machine for 2 or 3 seconds, and then would index to the next machine, and would kind of go through, and then would show the overall equipment efficiency so you could see how the whole system was running. And it would kind of scroll through those things. And it really worked quite beautifully, interestingly enough. And so I don't know if anybody else has had those challenges, but would be interested to see if anybody else has solved this problem a different way or
Well, some of the work I do down in Miami is similar to this in that it's a giant process plant, and they probably have hundreds of cameras located around the plant looking at different things, more from a security standpoint, because they're FDA. So you want to make sure that they actually had a situation where some bacteria got into a product, and they put a lot of the cameras in there to make sure that if anybody was cutting corners and things like that. They film everything 24 hours a day, and they're able to go back and look at any room and wind back and see what happened in that room. It's kind of had the side product of being able to do a little bit of machine debug. They can see when things go down, possibly what was going on in that area when the machine went down. So cameras are cheap nowadays. Yeah.
Yeah. And one of the ways, beyond that, to add on those cameras, that's a good thing. So we have inside of these systems, we have these web cameras which go to a kind of a video recording system, right? And so it's basically always recording. And so, the machine's going to production, we get a call from the customer, we can go in and kind of find the time when that fault happened and kind of watch and see what happened and help troubleshoot a problem remotely. It's another kind of a beautiful thing of some of the technologies that we have available to us today. Kind of the last thing on the trends I wanted to spend some time to talk about was, the show me the data concept. Everybody wants more data. They want to know what's going on with their system. How do I get the most out of my automation equipment? How do I make it run the longest, get the most production? And so one of the ways that we have targeted solving that problem is through a product that we've developed called OEE Optimizer. And it's really built on the concept of, you can pick any sort of time window that you want to look in. And so in this particular window, from October 25th at midnight through October 26th, you're kind of seeing the output for a couple of different machines here, right? And so you can see the overall OEE at 84.55%. And it looks like my availability was what was hurting me the most in this particular instance. And so, how can we tackle and improve our OEE? Well, we need to get that availability number up in this particular instance. So one of the things that we would, use a tool like this for is let's go look at our downtime events. What's taking away some of our availability? And so you're able to toggle between, well, what downtime events or faults are causing the most downtime in terms of time, or what's the most number of occurrences? You can toggle between time or occurrences. And so, if we're able to solve the top 2 or 3 of those, we're going to get the most impact. We're going to see the biggest increase if we can knock those top 2 or 3 items off this list, right? So it really gives us the tools to know what we need to go fix in what order. And so through this tool that we've used at one of our customers, we're able to, really have the tools in place to go solve these problems, fix these reject reasons. And we've seen that we're able to, guide and coach and mentor them so that through solving those problems, they can increase their OEE from, the mid 80s up into the 90s. And so it's really just having the data so you have the tool set to know what to go tweak and how to improve the machine. Any questions on this? Or
so do you get many calls to retrofit existing machinery with this versus putting it on your new equipment?
We have, to date, we have only been putting this on new equipment that we've been providing. And so that is a little bit twofold in why that's the case. One is that's all the bandwidth we have to do it right now. It takes, more resources to go find those opportunities and go figure out how to implement it in their particular system. But we do anticipate that being what we'd like to do, Frank. We'd like to be able to deliver, solutions where we can sell this OEE optimizer to a company that has some existing automation equipment, things of that sort, right? So they can get that insight into their equipment and figure out how to maximize their production output. Good question.
Is this something you're standardizing on new equipment, especially for pharmaceutical, or are you just saying this is part of what you're buying, or is it an option, or what?
Yeah, it's actually an option. So we kind of include it for free for the first year, and then it's kind of a subscription-based model moving forward. So after the first year, you can choose to continue it if you so desire. But we are providing kind of as a standard on new machines for the life science industries. Yeah. Now there is some, has to be some exceptions to this, right? So there's some customers that might have an existing system in place, right? Or they have their own way of doing this. And so those particular customers may not get this, right? We would just work with them to, do it what they're already doing. But we see a lot of customers haven't really solved this problem. And so this is a way that we can help them do that.
Yeah, Frank, I might add to that it can be used as a tool for getting through the debug process as well, right? Where you're getting to the later stages of debug and you're trying to fine tune and capture issues. And then furthermore, once it's installed at the customer's facility, it's really beneficial in helping them to understand where their shortcomings are. Many times they really don't have operators that have been trained sufficiently, right? And you start to recognize that a lot of the downtime is either due to operator inattentiveness, availability, and it's really eye-opening for the customers, right? They'll eventually grasp onto this as a tool and really use it to their best benefit. I think one of the installations that we currently have, there's 40 some people, I think, that are actively viewing that on a daily basis. So it's everything from the floor technicians all the way up to, senior management level. So it's proven to be very valuable.
Yeah, we can even set this thing up to where, it emails out reports at a particular frequency. So, every morning you can show up and see how my machine ran for the yesterday. And, I see, machine 2 had this issue. Let's go figure out what we need to do to solve that problem and kind of put some things in play in motion to solve that, right? So we've seen some good outcomes from that. All right, so shifting gears, I'd like to talk about something that's near and dear to my heart, as Frank's as well, and that is NTH University. We have focused a lot of effort here at Automation NTH in our training program. There's a lot of companies out there that need controls engineers, and not nearly as many controls engineers as there needs to be to support all those companies. And one of the ways that we have kind of solved or tried to solve that challenge to a certain extent is to come up with a program we're able to bring in folks and kind of put them through our own training steps so they can learn the basics of what we do in systems integration. What does a controls engineer do? What does that look like? And give them the building blocks so they can be successful. And so we developed this program. NTHU was really kind of built on the concept of bringing in young people who are finishing up school, college, they're within a couple months of graduation, or have just graduated, so they can come in as an intern or an apprentice. And we really, traditionally we would have the systems integration path you see in the table on the upper right-hand corner. And, they might go through these series of 4 classes with an introduction to controls. What do we do in this controls business? And then introduction to panel fabrication, actually kind of learn about electrical requirements, work in our panel shop, learn how to read prints, get your hands on these real components, and figure out what does it take, to actually put this wire in this terminal, because there are some space requirements that you need to know about. So when you're later doing design, in your mind, what it takes to actually build that system, right? And so that's valuable information. And then we do an introduction to PLC programming. PLCs are the backbone of automation systems. And so, much like the photo that Frank showed earlier, we have in our lab in the lower right-hand corner, you can see some images of these little conveyor systems. These are our little mini production lines. And so all this training is you learn by doing, right? You don't really learn a lot by reading and not actually getting to drive a little bit. So you need to learn by doing. And so all this is very hands-on. You can see the little control systems hanging on the board up there. We start with Micrologic's PLC. It's an Allen Bradley product. They're able to actually write the code, watch the machine run, go through that debug process, and figure out why this doesn't work. And it's very simple. Parts come down a production line. We have them kick them off into a reject bin. and all the good parts go off into the line, right? And there's a simple start stop button. But going through that process, you quickly realize that, 20% of the efforts to make the system do what it's supposed to do, and 80% is all the fault recovery and exception handling and edge case. And so, through our NTH University, it always is kind of fun for me to see students come in and they go through this hands-on exercise. They get it where they think it's going to work. And I have a knack of going out there and breaking their program pretty quick. And so that's kind of the process of what happens, what happens if the air is turned off? Well, then the cylinder is not going to advance, and you can't let parts just keep going by, right? You got to use your sensors on your cylinder to stop the system. And so they kind of learn those skills in the PLC programming class. And then we go to the introduction to control design. So as a company that does design work for control systems, we use AutoCAD as our package. And so they learn how to use AutoCAD and actually generate some drawings for a small control system. And at the end of that, we give them a sample control system. I give them some different bucket of parts. Here's a Siemens or a Mitsubishi or an Omron, whatever. And they have to go through and do the research and figure out how that's going to be designed, actually generate the drawings, order the parts, build it, program it, and debug it. That's kind of what we do on a big scale in our systems integration business. And, the students are really good at that. We're able to, extend them an offer and bring them on full time. And beyond these kind of the introduction classes here, we have like another 20 classes that, even if once you're hired on full time, you're able to learn about. So we just released the Introduction to Robotics class. So you got a little Epson robot there in our lab, and you're able to get online and learn about the basics of robotics, things of that sort. And so, one of the things that we do and is we really invest in training is important to us. And we engage Frank to help us with a lot of these things. We have our customers come in and see our lab and think this is great and have asked us, how can we get trained, right? And so we've done a lot of focused, this training program, NTH University, going through the 101 through 104 classes is probably a 3 to 4 month process because there's lots to learn in those to really get all the juice of the learning that's available there. And a lot of times our customers can't come for 3 to 4 months. Obviously, they got other things they need to do, but they might have a week or something. And so we have put together some kind of 1 week intensive courses, and that's where we bring Frank in to help us do those trainings. Now, that being said, we, in our efforts to always kind of provide the most value to our customers, we actually have brought in, an NTH University student to go through the full 3 to 4 month period process. And the end result was that intern candidate was hired as a full-time hire for our customer. And so in this case, we actually kind of went through the training process to help this customer have a trained person that could help maintain their automation equipment moving forward, right? And so that's just an added service that we have. But hopefully, you can find a company that, values training and, that's kind of one of our core values here at Automation NTH is folks that are just curious and always want to learn. So we try to facilitate that and help people get where they go. We got a great vision lab, so we can do lots of testing and setup. And we lean on Frank a lot in this particular area. Any questions on this or anything you want to add, Frank?
One thing I wanted to add, it's not real obvious from some of these pictures, but when their interns come in, at least at the beginning, they got different platforms that they had to develop. So maybe the first few guys did standard things like Allen Bradley or Siemens, but very quickly they were moving on to doing Mitsubishi or even I think a building management system you guys did. They'll do a similar project, they make these conveyors run and things, but they maybe do it with Arduino or Raspberry Pi, or I don't remember you had something that started with a V, I remember, that was some real off brand that I'd never even heard of. So that's really neat because they end up having all these control panels with different platforms inside of them that may be, like a Modicon or something that you just don't see a lot around here, but you're able to maybe pull that thing off the shelf and use it after it's been done. So they have a huge rack of these panels with different processors inside it's pretty neat to see.
Yes, that's great, Frank. We actually have 4 intern apprentices right now. Looking at my board here. So we have one's going to do an automation direct as an example. We got a Wago, an Opto 22, and I got one that's going to do an IO Link trainer. And so, yeah, we're always looking for oddball, fun stuff that we can play around with and kind of learn new things.
Do you guys do any SCADA work? Do you have a SCADA platform? I know, of course, you use Alan Bradley's Factory Talk View, but have you done any, large enterprise type SCADA work?
Yeah, so the product that we tend to use the most in that space would be Ignition, which is this inductive automation product. And so it's a very powerful SCADA package. It's got some pretty eye-popping graphics. And so, and it's kind of wide open. So you can do a lot with it. You're not really handcuffed to, certain restrictions that we have found in other platforms. And so we really like the Ignition product, and would suggest anybody go check that out.
Yeah, that's also a little less expensive than some of the other platforms. I think probably some of the people in the academy here have heard of things like Wonderware, or of course Alan Bradley's Factory Talk View SE. But a lot of those platforms you pay per tag, whereas Ignition you get unlimited tags for one server. And I believe right now it's maybe only 23 grand for an installation. And they have a Inductive University online, and you can take that for free. And you can actually download their software, and you'll get about 2 hours of runtime, and you can go through all their exercises. So that's been very useful for a lot of customers. Yeah, I'm glad to hear you guys are using that. That's cool.
Yeah, they actually have a pretty great training program. So we actually have a lot of our new staff. That's kind of one of the first things we ask them to go through is the Inductive Automation Ignition University program.
Very cool.
I'm glad you brought that up. That's really kind of all I had, guys. I don't know if there's any questions, or we'd be happy to talk about anything else. Any questions anybody got?
Yeah. For me, I'm still a student, and engineering mechatronics department. And I eager to learn more about PLC. I know the PLC and how to use the TEA portal, and I'm all looking forward to know the SCADA also. But I don't know how to improve myself. I have only 1 year to be graduate in my university in Egypt. But I don't know how to develop myself. So if you have any advices to me to, or when I join to this university and taking this course, have a chance to work in the company or what?
Well, what country are you in, Mustafa?
Again, sorry.
What country are you in right now? Where are you located?
Africa and in Cairo, Egypt.
Yeah, so you're of course physically limited by whatever is in your area, but online, as I mentioned and Jeff was talking about, that Ignition University is free. You can download their software and you can install it on your computer, and it'll run for 2 hours. And of course, there's all kinds of resources online. A lot of people rely on the free ones on YouTube and places like that, blogs, PLC forums, things like that. But as far as physically coming to classes, of course, that's difficult. Here in the US, we have a lot of opportunities like this. We have classes that go into plants. A lot of times your plant may pay for your classes. I don't know if that works the same way in Africa, but for instance, I taught a class last week, and the students came from, 3 of them were from one plant, maybe 30 miles from here, right? So their company paid for them to go to 1 week of PLC training. Now, even though I say it's PLC training, we talked about all kinds of things. We talked about SCADA and HMIs and simulation and whatever the students wanted to talk about, right? So it's sort of customized. But but you're physically right. If you're located in another country, that's very difficult to come here and take classes like that. Or I imagine, I've heard Germany has awesome training classes in their local universities and things that outsiders can come and take. Or of course, NTH, Automation NTH teaches their customers. They can send their customers to these classes. So I don't have a real answer other than all of the online resources, you know, when you're in Africa.
Let me just add to that just a little bit, Frank. So, you know, certainly, you know, the internet is your friend. Use the power, invoke the power of Google. I'm sure you can find lots of resources. We actually, you know, through the Automation Academy, there's probably some opportunities in our Introduction to Programming, PLC Programming class 103 right there. We actually use Frank's book here. So, you know, through going through this book, there's lots of examples that you can do and kind of get the concepts of PLC programming. You know, what is ladder logic? How does it work? And so, yeah, just do your research and find opportunities to get plugged in.
Yeah, you're using TIA Portal. There's all kinds of good online resources for TIA Portal. I have a YouTube channel where there's some free stuff on TIA Portal, I believe. I think I have a couple videos on there. And they're not formal classes, but what I do on all my Odyssey videos, and I think it's I'll have to put up a link later, but what I do there is I just start a program from scratch, and I film it, and I show how you configure the hardware and how you would set up some routines, and all these little Odyssey programs are that. It's just me starting a program and continuing on. The Siemens Step 7 series has 12 videos in it. And even though it's not going to be like a school class, it does show me developing a program from scratch and carrying it all the way through a pretty elaborate simulation. So studying those things, even if you're on a different platform, even if you were on Modicon or something else, you can still learn from those videos, right? And apply what you get out of them as far as program structure and, you know, timers and counters are timers and counters everywhere. There are some differences. Obviously, some of the old stuff, timers used to, you know, time down in Siemens. That's a little confusing to people who have used Allen Bradley all the time, you know, and it may use, I don't know, BCD numbers instead of decimal numbers. So you'll have to apply it to your platform. But TIA Portal is completely IEC 61131 compliant. So anything you learn on, for instance, control logics would pretty well apply to TIA Portal also. So lots of resources out there.
Actually, I worked on TIA Portal and also using the Siemens S7 just to try more or a lot of projects. And I know, actually, I know how to use. And also, I will see your YouTube channel for these things. But I don't know what the next step I can do after learn more or after I do more projects in PLC and SCADA also. I'm not mentioned about to create a company, but how can we, as say Mr. Jeff, to create automation line from A to Z. These tough things or these things, the automation is the future, but what else I can do?
You know, beyond just doing your own training, getting, you know, completing your education, you know, find a company that you're able to get some training, right? There's no replacement for experience. And so you just need to reach out and see if you can find a company in your area that does some sort of automation work, or if it's not in your area, where are they, and find a way that you can get some experience.
So let me give you an example. When I got out of school, out of college, I was an electrical engineer, and I went as a 30-year-old freshman. And I already owned a house, so I was not willing to move to another city. I was unlike a lot of other students. And I kind of lucked into a job actually selling controls components. And it was great training because I learned how everything worked, right? So I worked for a small company, and the first thing they did was they put me through a little PLC class. And at the time it was DOS, right? It was old stuff. I had to program an Eagle Signal PLC in DOS because to sell those little PLCs, which were fairly new, I had to know how they worked. So I had to do some simple applications there. And I also opened up the catalogs and I read all the help files, right, for how do these sensors work. I had to sell intrinsic safety barriers from Pepperell and Fuchs. I opened up the catalog and I read all the specs. And then as I visited plants, right, to try to sell them this stuff, I would see those products installed in the plant and learn more about them. So I think there's kind of no substitute for just being around it. So for instance, Automation NTH, you know, immediately you get hired on as an intern, you're going to see machinery and panels and whatever. But if you don't have a company like that, the next best thing might be get in with somebody that at least you can visit those plants and you can watch what they're doing and that sort of thing. Does that answer your question at all? I think you're in Egypt, right?
Yeah, I'm from Egypt, and I wanted to thank you for this information and this advices. I'm really appreciate it, and sorry for asking a lot of questions, but I want to know. Thank you.
No problem. Great to see you too, Phil. You know, Phil's been at most of the webinars. As a matter of fact, the first webinar, Phil has been in the academy and he appeared with me and we just talked for an hour. So it's kind of evolved a little bit, but there's Phil. So it's great.
Guys, I have a super quick question too. Jeff was talking a little bit about the cameras in OBS Studio. I've had some interesting experiences over the past year, so I was surprised to see that pop up where I've kind of been implementing it. And as far as the cameras that are utilized, this might be a little technical, but what type of protocol are the cameras using? Are they just standard CCTV cameras, or are you using something that's newer or different? You know, I guess that's one of the questions that I have, because I've had some interesting kind of some troubles getting those set up, and the reliability of them has kind of been iffy when I set up kind of my foray into observation cameras, we'll put it that way.
Gotcha. So I'm not probably as familiar with the technical details of those specific cameras that you might want to know here, Phil. I do know that we are using cameras that they're web cameras that you basically plug in a PoE, power over Ethernet cable, right? That's just a single cable in, right? And they go back to our Ethernet switch, and ultimately we have a server that's got a basically they all go into this recording device, and that's how we kind of tap into them, is through that recording mechanism.
Okay.
So basically a DVR device.
Yes.
Which is kind of what I use too. I've used Lorex, and Phil, I can probably get the information from down in Miami because that guy's got hundreds of cameras. They are all Ethernet. I know that.
Yeah.
He's used the CCTV before, but I think the Ethernet and PoE cameras are maybe a little less expensive. He's had problems too. I think sometimes, like if you get DHCP stuff on there mixed with your static IP address stuff, that can cause problems. So I know he ran into a problem.
Yeah, absolutely. Okay, yeah, I found that interesting because a lot of people are using like OBS Studio for streaming and multiple camera angles for content production. And it's a little bit reassuring to see that's what people are actually using in industry. So that's reassuring and makes me feel good that I was going in the right direction with that. So thank you.
I just put the brand and part number up there real quick in chat as to what we're using. They're actually they're kind of just a high-end webcam, 1024p, and you know, maybe a little more ruggedized than what you might put outside your house or what have you, but looks like we pay a couple $100. And
Okay, great.
that's just one that we found that it's worked well. It's not to say that there wouldn't be others that would be compatible. And then as Jeff mentioned, we run those back to an NVR, right? A network video recorder with tons of storage. And that's been another great tool in conjunction with the OEE optimizer. And I think Jeff mentioned that earlier was, as the customer requires the automation and in the early phases of onboarding, they'll get interesting faults, right? And they'll tell us that the machine faulted at a certain time. Well, you go back and look and you see where somebody responded to a fault on the machine, but they didn't really correct the problem, right? They opened the guard door, maybe moved something, hit the reset button, and the robot crashed. Well, it wasn't the machine's fault, right? And that's really been very, very helpful. Having that, ability to go back and review that and use it as a learning experience and training tool, right? So.
Okay, I guess that brings one more question. One of the interesting features about like a Lorex system or the Lorex NVR is they've kind of incorporated, some of the latest systems have like some edge detection cases where they'll have person detection or vehicle detection in some of the home security systems. Are there any kind of malfunctioning machine detection features that you guys have been able to incorporate, or is that still kind of blue sky out in the future kind of ideas?
Yeah, I don't know of any instances where we've actually, got a rearward looking kind of trigger, right? Because the fault's already occurred. I used to call them anticipatory proximity sensors. They were the ones that would go off when it was almost there. But yeah, I think some of the AI functionality that is up and about and coming is going to be part of that, right? Looking forward to it, actually.
I think it's a fine line between the commercial systems that you get that don't really have much smarts in them and the low end of the industrial systems like the bombers and the banners.
Yeah.
Like banner and bomber both make some low cost machine vision systems, and they certainly do edge detection and things like that. Now, I had a guy come in on a consulting job a year or two ago using those little Arduino CCD cameras, which are only, I don't know what the pixel size of them, maybe 320 by 240 or something. And he was able to do things like that, edge detection. He was looking at a conveyor and he could tell when parts came down it. And those cameras are, I want to say $25.
Oh yeah, they're cheap.
Yeah. And so the brain was really more in the Arduino, or he may have been using Raspberry Pi. I think he was using Raspberry Pi, but there are certainly tools to do that. But I kind of talked him out of it. I said, by the time you've spent 1,000 hours trying to get this thing done, you might as well have just bought a little banner or a bomber or, somebody's low end vision system.
Well, thank you.
Well, Jeff, this has been great. I appreciate you coming on and all the attendees. And this is something we do every 2 weeks. Our next one is February 19th, I guess, 2 weeks from today. I try to have a guest on whenever I can. I think Doug Allward has kind of volunteered to come in whenever and talk about applications and things like that. All of us in this area kind of one way or another know each other. One of the things we all have in common, I think people have worked for some of the machine builders or other integrators have some things in common there. So it's kind of neat to see that. Dan, I think, goes way back and worked at Wright also. And of course, Jeff and Brent and Doug Allward, lots of folks.
Yeah, we have a fair number of former Wright folks on our staff. And then we continue to work with a number of those folks as caps, right?
Right.
So it's been Wright Industries was just an awesome training ground for anybody that wanted to be in the automation business. I mean, the size and complexity of projects that we encountered were pretty amazing. And, you know, it taught us, as I tell a number of people, it kind of taught us what not to do as much as what to do, right? And it's been very, very beneficial for us in getting our organization to the place it's at.
Honestly, if you're in this field, I think the very best path, the ideal path coming out of school when you do either mechanical or electrical, is to get into some kind of a custom machine builder, integrator.
Yep.
To me, that's sort of the peak, because you get to see the mechanical, the electrical, the systems part. For me, I had run a machine building company for 10 years, but when I went to Wright, I learned a lot more about the business side of it. How do these guys quote things that are, you know, $3 million, $8 million machines? How do you do risk mitigation on a project that size and make sure that you don't lose your shirt like I did, you know, when I would do projects? I built machines on a wing and a prayer, and you'd make money on, you know, 9 of them, and then you'd lose it all back on your 10th. So definitely going to work for somebody else and watching how they do it is a good way to get started, Mustafa. So if you could get in, if you're in the Cairo area, I'm sure there are people there that build, even if they're standard machinery. It's a great way to get into the industry and see how people build machines and program them. And there's no substitute for just thousands of hours of hands-on working on the equipment. That's where you learn. It's just doing it, right?
Learn by doing. You're right. Well, thanks for the invite, Frank. I enjoyed being on your webinar today.
Well, thank you. Yeah, it's been great. And
good job, Jeff.
Recording of this. I put this on YouTube. I stick it out there and put a link on LinkedIn, and I've got a Facebook group called the Automation Academy. And of course, my new venture is the Automation Academy. It's on the automationllc.com site, and always looking for folks to join. People like Phil have been great there. He's been helping me out since I started it, and it was great seeing everyone. Thank you for coming.
Thanks for hosting, Frank.
Well, thank you.